All right, unit circle today, and then we're going to talk about inverse trig and how that works. So you should know the unit circle forwards, and then inverse trig means you know your unit circle backwards as well. So I've given you unit circle as a reference there. You should be comfortable in radian mode of all the quadrants. Let's just quickly review what the numbers mean. So if you see a 1 and a 0, what does the first number mean? The first number doesn't mean x. On a Cartesian coordinate it does, but on a trig unit circle, the first number means the sine value, the cosine value, alphabetical order. And then the sine value comes second. All right, so if we have a comma b, cosine of x is first. Actually, let's not use x. Let's be good about it. Cosine of theta and sine of theta. All right, so the first number is the cosine. The second number is the sine. So how do you get tangent? Okay, you divide them. You take the two numbers and divide them. Where do you run into trouble then? If you take those two numbers and divide them in tangent, where do you run into problems?
Denominator is 0.
When would the denominator be 0?
Pi over 2.
2. Okay, that could be a problem. Okay, so the tangent of pi over 2 would be 1 divided by 0, which is undefined. Okay, the other time we would have a problem would be at 3 pi halves down there for tangent. Okay, then how do you get cotangent?
Cosine of x.
Okay, so we do it the other way around, cosine over sine. How do you get like secant and cosecant?
1 over.
Okay,
1 over.
don't say 1 over. Get into the habit of the reciprocal of. Okay, so the reciprocal of. So if I wanted to know, let's see, the cosecant at 5/6 pi. Okay, the cosecant at 5/6 pi. Find 5/6 pi. And if you know the cosecant, raise your hand. Sam?
The reciprocal of negative rad 3 over 2.
Okay, the cosecant goes with sine.
Oh.
Cos don't go together. Cosecant doesn't go with cosine. Okay, the cosecant goes with sine. So,
The reciprocal of, well, just 2.
okay, the reciprocal of 1/2, which would be 2, right? Okay. So if you want to go in a negative direction, you're going to go down this way. All right. So let's say 7 pi fourths. What's its negative equivalent? Okay, 7 pi fourths. It's sitting there in quadrant 4. Okay. Raise your hand if you know what a negative equivalent of 7 pi fourths would be. Okay, Luke.
Negative pi over 4.
Negative 1 pi over 4 or 1/4 pi. Sure. So if we were going to this position, if I say 7 pi fourths, then I'm assuming you went around this way to get there. If I say negative pi fourths, then I'm implying that you're going that way to meet up at the same position. Okay. There's tricks. I don't know. Did you probably learned tricks in ham last year of like how to remember the numbers? I know. Okay, so if you to keep them straight, like I only ever really memorized this one. I know the first quadrant. Once I know the first quadrant, I can mentally figure out the other ones based on negative signs for the other quadrants. So I really only ever focus on like this whole section here. Okay, I do that one. Memorize those. I memorize that the x values, okay, it's, I always think of it this way. I don't know if you guys do, but like, oops. I think of it as, I put a square root there. And it's square root 1 over 2, square root 2 over 2, square root 3 over 2. It goes so 1, 2, 3. And then in the other direction, if I think of it as the square root 1, square root 2, square root 3, they have to, one goes down, the other goes up. All right, so you can use that for reference. All right, let's do some actual questions with that. So find the cosine. Sorry, I didn't have my pi thing. I wasn't working in my note. I made this in, when did I make this in? PowerPoint, I think. Google Slides. Google Slides and pi wasn't working, so I just wrote pi. All right, who's got the value of the cosine of negative pi over 2? Okay, think about it a minute. Write it down. Go ahead and write it down. I'll give you 10 seconds to think about it. The cosine of negative pi over 2. Okay, 5, 4, 3, 2. All right, David? David. Sorry, not Aiden. David. But maybe Aiden wants to do it if David doesn't have it. All right, we're passing to Aiden.
0.
Good job. Say it with confidence.
0.
0. Okay, correct. Negative pi over 2. You're at the bottom of your unit circle, and the x value there is 0. All right, the tangent of pi over 3. All right, I'll give you a little 10 seconds to figure that one out too. Five, 4, 3, 2, 1. All right, who's got this one? Tyler.
Rad 3.
Rad 3, good job. Rad 3 over 1, so it was rad 3 over 2 on top and 1 over 2 on the bottom. That's sine over cosine, which simplifies to rad 3. All right, great. Okay, now inverse. When you work on inverse trig, the answer should be the radian that matches it. So you want to find the right coordinate. So if I say sine inverse of negative 1/2, that means the position where the sine value is negative 1/2, and what is the pi value? So question mark pi, what pi is the sine value of negative 1/2? All right, so think about that for a minute. Not a minute, think about that for 10 seconds. Okay, what pi position? And what quadrant are you in? Okay, 5, 4, 3. David, you got this one? 2, 1. You thought you were off the hook because I already called on you once. What you got? All right, David, stick with me. Go ahead.
2 pi over 3.
No, shoot. Okay. All right. Somebody else. All right, Sean.
Pi over 6.
Pi over 6. Nope, that can't have a negative sign value. Pi over 6 is in quadrant 1, so it can't be an answer in quadrant 1. We know that. Carla?
7 pi over 6.
7 pi over 6. And what quadrant does that put you in?
4.
That puts you in quadrant 3. Okay, anybody else have another answer? Okay, Brandon?
11 pi over 2.
Anybody else have another answer?
Negative 1/6 pi.
Negative 1/6 pi. All right. Now, I didn't know if you would remember this from Ham or not. In inverse trig, the domain excludes quadrant 3 completely. You can never be in quadrant 3. There's a reason for it, and I'll tell you in a minute. So anything in quadrant 3 is automatically cannot be possibly an answer. All right, so we have to eliminate this one. Just an inverse trig. Okay, now what some people are, well, why not Brandon's 11 pi over 6? That's not in quadrant 3. But how did he get to it? He went around, round, and then he went through quadrant 3. And you can't go through quadrant 3 either. Okay, the answer has to be the position. So let's look back at the unit circle. If we erase some of these things, it's got to be this position. But you got to get there in the shortest way possible that doesn't require you to go the long way around through quadrant 3. So that's why negative 1/6 is the correct answer for that, for the inverse of sine. Okay, the reason inverse doesn't work, if you remember from last week, an inverse function has to pass what test? What does a regular function have to pass? What test? Vertical line test. What does an inverse function have to pass? The horizontal line test. What's wrong with the sine function?
This is not tested.
Oh, it totally fails the horizontal line test. All right, there's only a certain section. Okay, so here. All right, do you know which section on the unit circle this part of the arch represents?
First quadrant.
It's quadrant 1. Okay, and then this one is
2.
quadrant 2. This one is 3, and then this section is 4. Okay. All right. Well, what's this one? This is also 4. Okay. I'm only allowed to use quadrants where it passes the horizontal line test. So if I start here at the origin and I go through, as soon as I get to quadrant 2, it fails the horizontal line test, so it can't be that. Okay. And then I can't use quadrant 3 because it fails again. So I'm only allowed to use this part of quadrant 1 and the backwards part of quadrant 4. That's all you're allowed to use for the sine graph. You can't use any of the other ones. That's why. Okay? So quadrant 3, never. All right, how about cosine of negative rad 2 over 2? Okay, cosine of negative rad 2 over 2. What pi position, we'll add that, question mark pi, where would that be? Don't use quadrant 3. Okay, Tyler?
3 pi over 4.
Okay, good job. So why are we allowed to use quadrant 2 for this one? Because the shape of cosine is a little different. Remember that cosine looks like this. Cosine starts up here, goes down, and then goes down again. So quadrant 1 is fine, and quadrant 2 is still fine. Because both of those pass the horizontal line test. But what about the backwards quadrant 4?
No.
Okay, oops, the backward quadrant 4 now fails. So for this one, I use quadrant 1 and 2. I still don't use 3. So 3 you never use. In sine, you use forward quadrant 1 and backward quadrant 4. And in cosine, you're allowed to use quadrants 1 and 2, right? So good job on that. All right, any other questions on inverse? Yeah, Andre? Tangent is the same as sine.
Okay. Yeah, all right.
And so then conversely, like cosecant would be the same as tangent, cosecant, sine, they're all in 1 and 2. Okay. Okay, the other thing to remember about inverse functions is how coordinates work. So the point A, B on a regular function, so like say it was the point 2, 7 on a regular function. What are you guaranteed is going to be on the inverse function? What did we do algebraically when we were finding inverses? What did we do with the variables?
We switched them.
We switched them, right? We switched x and y?
Yeah.
Okay, so we do the same thing here. So if the point AB is on function f, then what point will be on function f inverse? BA, right. So you're guaranteed that that is true. Also, what it switches are the domain and range. We talked about that on your quiz. That the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. And a function will only have an inverse if it passes both the vertical and the horizontal line tests. Okay, so all those things are all true about inverses. All right, and we just talked about the domain of inverse functions. So sine 1 inverse has a domain of 4 and 1, and then cosine inverse has the domain of 1 and 2. And then tan is the same. Okay, last thing. This last inverse question. Actually, last inverse section. The sine inverse of 4 over 9. Is 4 over 9 on the unit circle? No. Okay, it's not. So then we use a triangle instead. Okay? So 4 over 9 is not on the unit circle. It's not like square root 3 over 2 or one of these nice ones. It's a triangle. It's a right triangle. So this is SOHCAHTOA trig. So go ahead and draw a right triangle. The scale doesn't really matter. Make sure you label your corner as right. And then I usually put my theta in the lower corner down there. Sine inverse of 4/9 means I can switch my x and my y. Okay, so I can switch things around. So that means that sine of theta is 4/9. If theta is sine inverse of 4/9, then sine of theta is 4/9. Those two things are equal to each other. They're equivalent. And if you remember from SOHCAHTOA trig, what does the 4 in the top of a fraction stand for? Opposite. So, SOH. So we have the SOH means the top number is the opposite. And what does the 9 represent? The hypotenuse, the H part. So on my triangle, I plop 4 on the opposite side. And I put 9 on the hypotenuse side. And if I'm any good at math, I should be able to figure out the missing side. Okay, what famous mathematician helps us do that? Who? Pythagoras, right? The Pythagorean theorem. How can we figure out the bottom side? What is
squared plus b squared equals 9.
All right, so 4 squared, a squared plus b squared equals c squared. So 4 squared plus b squared equals 9 squared. That's 36 plus b squared equals 81. So what does b have to be equal to? Square root of what number?
36. It's 16.
Whoops, yeah, sorry. There we go. All right, square root of what number? 65. So this can be the square root of 65. Okay. So the question says, find the 6 trig values. So what are the 6 trig values? Sine, cosine, tangent, secant, cosecant, cotangent. So I should be able to find all 6. All right, so I already have the sine. I know that the sine is 4/9. So then I should be able to figure out the cosine. So rad 65 over 9. I should also be able to figure out the tangent. Who's got that one? TOA. 4 is the opposite. 65 is the adjacent. So we're looking at SOHCAHTOA. All right, those are the first 3. And the second 3 come really quickly. CSC theta is going to be 9/4. Secant theta, 9 over rad 65. You do not need to rationalize or simplify. You may leave it like that. And then tan theta, rad 65 over 4. So those are the 6 values. Oh, whoops, I wrote tangent again, didn't I? I think I already moved it, so it's not going to let me erase it. So cotangent, thanks. All right, so you use that when you don't have a good unit circle value. If it's unit circle value, use unit circle. But if not, all right, so here's our last one. Find the value, not all 6, but just find the tangent value when the cosine is going to be, an inverse is 3/7. So the implication is that the cosine of theta is equal to 3/7. So you're going to sketch that was a really poor right triangle. You're going to sketch your right triangle. 3 is the adjacent side because we're dealing with cosine. 7 is the hypotenuse. So I should be able to figure out, can anybody do a mental Pythagorean theorem kind of quickly on the fly? Square root of what is going to be my last one? Square root of 40. Okay, or 2 rad 5. And so then we just want tangent. And so I didn't ask you for all 6, I just asked you for 1. And so the tangent would be 2 rad 5 over 3. Okay, one thing, don't write tangent equals. There's no, that doesn't, what?
Oh.
Okay, please write tangent theta equals, not just tangent equals. Okay, Andre.
Oh, why is it 2 right side?
The square root of 40 can be, oh, it's not, it's 2 rad 10. Man, I am rusty. Is that better? 2 rad 10?
Can you, 2 slides of previous stuff?
Yep.